Unit 2 Chemistry, Chapter 18, Part 1, looking at how we analyse salts in water, which can be any ionic substance, remember? When we say salt, that's what we mean. Now there's a number of different techniques we're going to look at. The first one is how we analyse things by mass. So essentially we are weighing things using some accurate electronic balance. And we use that to determine things like what percentage of a mixture is water. Or if we've got a dissolved substance and we precipitate it out, we can find how much of that dissolved substance there was. Or we can also use it to find empirical and molecular formulas. There's a whole range of different things we can find using these techniques. For all of them, we need to use stoichiometry, but now we're doing mass stoichiometry, which essentially means we start with the mass of one thing that we know about, and we're finding the mass of another thing. And of course we're doing that by converting from mass to mole using the molar mass, because our stoichiometry is always based on molar ratios, not any other type of ratio. So 4 steps. Firstly, we write the full balanced equation. We then have our known substance and we use its mass to find its amount in mole using the molar mass. Then we use that molar ratio to find the amount in mole of the substance we're interested in. And then finally, we calculate the mass of the substance from its amount in mole. Remember, amount, you see that word in chemistry? That means mole. That means amount in mole, always. So for instance, if I've got 70 grams of iron and I want to know what mass of iron 3 oxide is made when it rusts, we start by writing the equation. Well, actually, we start by making sure we get this formula for iron 3 oxide right, and then we balance our equation. And we make sure we remember that oxygen gas is diatomic. We then use the molar mass of iron to find its amount in mole. So 70 divided by 55.85. It's going to give you 1.25 mole. It's actually on your calculator going to have a much longer number than that, but you don't need to write down every digit. You do need to keep that number on your calculator to use in the next step though. Now, 4 moles of iron give you 2 moles of iron oxide, so it's half as much. Okay? So if we take this 1.25, divide by 2, that's going to give you 0.63 moles. Again, your number on your calculator is going to be longer, still don't round it on your calculator. Okay, just write down an abbreviated one. And now we're going to use the molar mass of iron 3 oxide, multiply it by the amount in mole, and here we find that our mass is 98.95 grams. Now we're going to go back to our question. We're going to see that this is 2 sig figs, so we are now going to round, and that's going to tell us that we're rounding to 99 grams. Okay, because this is the last figure we're dropping, so that's going to make this number round up. Another thing we can do in analysis by mass, one thing we can do is find the water content. So biologists use this a lot to find the dry mass of organic matter. So we find out how much water there is, the rest of it's the dry mass. We also use it in food production because in some things, some food producers can be a bit cheeky. They try and do things like inject chicken breasts with water so that the weight goes up and you think you're getting more food. There are limits to how much they're allowed to do that. Okay? So to do this, really simple. First we weigh the sample, then we heat it in the oven at over the boiling point of water, then we cool it, and we reweigh it. Then we keep doing these 3 steps until the mass we get here stays the same for 3 or so weighings in a row. Okay, so say you had some soup, can of soup, we know its initial mass, we're going to heat it and cool it, and it's going to drop a lot. We're going to heat it and cool it, it's going to drop, but nowhere near as much. We're going to heat it and cool it, oh look, it's staying the same. So this is now the mass that we're going to use. The mass of the water in the soup is its initial mass minus the final mass. Okay, so we find that we had 198.8 grams of water in there. Then we can find the percentage by mass. So this mass divided by the initial mass times 100, and that tells us our soup was 89.1% water. Okay, and obviously we're quite happy with that because that's exactly the sort of thing you'd expect for soup, that it is mostly water.